네, 여러분 안녕하세요. 물리화학 수업에 오신 여러분들을 환영합니다. 네, 수업을 좀 시작을 해보도록 하겠습니다. 이번 시간에 여러분하고 같이 나눌 내용은 이제 기체 방정식에 관련된 내용을 여러분하고 같이 이야기를 해보도록 할 거예요. 기본적으로 물리화학 같은 경우에는 연력학이라는 수업과 굉장히 좀 오버랩이 많이 되는 수업입니다. 특히나 이제 이 물리화학에서는 기체와 관련된 연력학적인 내용들에 대해서 여러분이 계속해서 같이 배울 내용이고요. 그래서 어떠한 그 기체 평형 혹은 연력학 제1, 2, 3법칙과 같은 관련된 여러 가지 법칙들에 대해서 여러분이 배울 거고, 그런 것들이 어떻게 우리의 어떤 반응이라던가 그런 부분들에 적용이 되는지에 대해서 여러분하고 같이 이야기를 나눠보도록 하겠습니다. 기본적으로 수업은 영어로 진행이 될 예정이고요. 그런데 필요한 부분에 대해서는 제가 일정 부분 한글로 서머리를 좀 해드리도록 하겠습니다. 하지만 기본적인 언어는 영어라는 점 여러분이 아시고 가시면 될 것 같습니다. 네, 그럼 본격적으로 수업을 한번 시작을 해보도록 하겠습니다. Okay, so shall we start this today classes? So part one of this classes is about the equilibrium. So in this section, we will talk about this equilibrium of the gases. So there is a lot of status of the metals, but we can call that kind of equilibrium as the status where there are no change of property. So there is the different types of property change, such as the mechanical property change, or temperature change, or some other types of change. But in this kind of equilibrium status, there will be no changes. So this is the kind of start of understanding of this kind of property of these gases. So actually, most of this kind of theory or some kind of equations related to this physical property of the materials usually started from this kind of equilibrium status, because the opposite world of this equilibrium status is a dynamic status. So in that kind of a dynamic status, the matter is moving. So what this means, we have to consider a lot of different variants. So that means the making some kind of fixing equation for the kind of phenomenon is really difficult. So that's why we always start with this kind of equilibrium states of the metals to set up some kind of a basic, how can I say, basic equation. I mean, basic physical property of the materials. So that's why we will start this equilibrium for this physical property one. So especially for these gases, there is some kind of equilibrium status. So we will talk about such things here. Okay, so this is chapter 1. So it's not actually not so difficult actually. So most of part you might be already heard from some kind of basic courses, such as the general chemistry, which you might be learned in your freshman years. So this is kind of the reminding this section plus with some kind of additional the knowledge for this kind of equilibrium status of gases. So this is a chapter 1, and chapter 1 of the title is the properties of gases. Okay, so let's see. Okay, so as I told you, the starting of understanding of some kind of theory, uh, usually from some kind of ideal cases. What this means? If there are a lot of variants, then it might be difficult to set up some kind of the equations for the kind of physical motion of the materials. So that's why the people usually start from some kind of ideal cases. So uh, so just making some kind of ideal cases and then the adding, I mean, some kind of providing some kind of additional point to that kind of ideal case, and thereby some making some different types of situation. I mean, some different types of equation for the different types of situation. So that's why we start from this perfect gases. So perfect gas is kind of the gases which is in status of equilibrium. So we can call that kind of a perfect gas. So actually, that kind of perfect gases, that kind of perfect gases is not too. I mean, it's not easy to see in your real life, but usually the kind of perfect gases is kind of they dealt in this kind of some theoretical situation. So, but anyway, as I told you, this perfect cases is a good starting point to understand about this kind of a situation. So the start of this physical chemistry is also from this perfect gases. So what is the key point for this crisis? First, we will learn about this stage of gases. So equilibrium could be one stage of these gases. But anyway, so I will talk about more details about this stage of gases. But anyway, the key point of this chapter is the, let's read it together. Each substance is described by an equation of the state. So what this means? So the any of the materials, what you have been interested can be described by the equation of a status. For example, if you have some kind of how can I say, you have a balloon like this. In the balloon there is some air. But even though we cannot see this air, but if you want to describe about this kind of a state of this air, you can use some kind of an equation which can describe this gas stage. So this is the key starting point of these perfect gases. So which parameter can be related to this kind of equation of the state? So first, there is the pressure. You know pressure. So again, so if we have this balloon and there is the air, and this air make a pressure to this outer plane direction, and then the outer gases also make a pressure to the opposite direction to this balloon. So they kind of things called the pressure. So maybe, yeah. So I hope, yeah. So because you are engineer, you all of you guys know about this pressure. So anyway, so what is the definition? I mean, so what is the theoretical definition of this pressure? So pressure is a force divided by the area. So what this means? There is the certain area, and there is this certain force. And if we divide this area, sorry, if we divide this force by this total area, then that can be defined as pressures. So this pressure is important because this pressure provides a criterion of mechanical equilibrium for systems free to change their volumes. So what this mean? I mean so to understand about this sentence, we have to understand about this mechanical equilibrium. So what is the mechanical equilibrium? So if there is some kind of okay, so the important thing is the mechanical equilibrium here. So here you have to know, you have to remember this pressure, and pressure means the force divided by this area. And this is the criterion of the mechanical equilibrium. So we will talk about this mechanical equilibrium in the next slide. But anyway, briefly. So if there is this kind of boxes, and there is this some movable wall, and if there is some force here, and also there's a force here, and if there is the gaps between these two forces, then this movable wall, what do you think? How this movable wall will work? Maybe this will move through the large force, from this large force area to this small force area. But if there is the mechanical equilibrium state, then this wall will not move. What this means, there's no mechanical the movement in the system. So we can call that kind of things as a mechanical equilibriums. So here you don't need to fully understand about this sentence, but the thing is that I'm talking about this kind of a word is repeated is because this is kind of a really basic word to understand about this stage of gases, and we will how can I say, we will talk about, I mean, you will see a lot of many times in the future in these classes about this pressure and this kind of force divided area or mechanical equilibrium. So that's why I'm talking you several times. So this is a really basic sentence. So again, let's just read about again. So pressure is the force divided by area, and this provides a criterion of mechanical equilibrium for systems free to change their volumes. So this is the basic things. Okay, so the other thing is the second key point is the pressure is measured with barometers. So actually, this is not so significant point, but anyway, so we have to know as a common sense how we can measure this pressure. So anyway, the pressure. So what is a barometer? So I will talk later. So anyway. So pressure is measured with the barometers. So okay, so also there is some Zero's law. You might be already heard about this thing in the in the, how can I say, the forehand classes such as the physics, how can I say, it's the general chemistry. So anyway, through the Zero law of thermodynamics, so temperature provides a criterion of thermal equilibrium. So there is a two concept we face in these classes. First, the pressure here, and second is temperature. So this pressure is a criterion of mechanical equilibrium, and temperature is a criterion of a thermal equilibrium. So there is some kind of a law for this thermal equilibrium, which is the zero slope. So what this means? So I like to here. So this is a zero slope. So what is zero slope? If substance A is in thermal equilibrium with the substance B, and B is in thermal equilibrium with the substance C, then C is also in thermal equilibrium with the substance A. What do you think about this law? So actually, yeah, it's looks like a pretty simple. I mean, it's kind of like this kind of. So if A has a thermal equilibrium B is thermal equilibrium C, then A is also thermal equilibrium with C. So this is a quite, how can I say? So actually, when I first meet this zero slope, I didn't understand why this can be called as a law, because this is how can I say? So just a common sense. I mean, this is a really simple mathematical situation, but the providing evidence for this kind of a zero slope is the really, how can I say, it's a really critical the findings in our the thermodynamic theories. So that's why this is looks really simple, but this is a really the critical laws. I mean, and also really important initial starting point for this understanding of thermodynamics. So maybe, yeah, I think you guys, all you guys understand about this zero slope. So anyway, because of this kind of zero slope, uh, the temperature provides a criterion of thermal equilibrium. So what this means, I mean, the it's the same thing. So if there is a box and there is the, how can I say, some kind of membrane which can block these two boxes, and there is the large T high temperature and there is a small temperature, and if we remove this the blocking walls, then the temperature could move from this high temperatures the small temperature, and in some point there is the no change of temperature between these two areas, then we call that kind of situation as thermal equilibrium. And if there is some kind of area C, and so regarding this area C, if there is the area A is in thermal equilibrium with the C, and B also thermal equilibrium with the C, area C, then this A and B also will be a thermal equilibrium status. So that's the zero slope. Okay, so this is the key point what you will learn through this chapter. So maybe if you fully understand about these three key points, even some kind of the behind the meaning of this each sentence, then I think you don't need to continue this class. Just go through the next steps, because the all things I will talk about here is the related to this key point. Okay, so this 1, 2, 3, 4 is the keywords or some basic terminology for these classes. First, so physical state. So the physical in Korean is the 물리. So this physical state is kind of the how can I say the kind of it's a the physics is related to some kind of a motion or some kind of the in view stage of some substance. So this physical state. So the definition of the physical state can be written as the physical state of a sample of a substance, which means this is its physical condition. This is defined by its physical properties. So physical property is related to this kind of mechanical property or some kind of temperature. This means this thermal property. Some kind of optical property, electrical property, all this kind of the property which is related to some kind of motion of a substance called as a physical property. And physical state is defined by this kind of their physical properties. So it's a the basically when people say about some people's physics, then we can call that their, how can I say, is their how they can they run fast, or how the big stuff they can lift up. So that kind of property is related to physical property. And physical condition is also defined by this kind of physical properties. Okay, so the equation of state is simple. I mean, this means the equations which is related to this physical property called as the equation of state. So this is kind of basic terminology. So I will use this kind of terminology to explain about this kind of state of gases in the remaining part of this chapter. So you have to learn, understand about this physical state and also equation of state. So the most general form of an equation of a state, so is the P equal function tvn. So what this mean? So this is the function which is the have a variance of temperature and volume, and it's the number of molecules. So this is the very basic form of equation of a state. So the equation of a state of perfect gases can be described as the P equal nRT over V. So you might know about this. You might already know about this equation, right? Because this is the quite famous equation for the equation of state of perfect gases. So in Korean, this is the equation of state is the how can I say, 상태 방정식. So the equation of state of perfect gases is the 이상기체 상체 방정식. So all the equation which is related to this state of gases is derived from this the equation of states of perfect gases. So this is really simple, and you guys know all about these things, but this is the most important equation to understand about this physical chemistry of gases. Okay. So this is the key points and the basic terminology for the state of gases. So I hope you guys have some kind of the point for this the remaining classes. Okay, so let's go to the next slide. Okay, so yeah. So I will talk about a little bit more details about this terminology. First, let's talk about this pressure. So pressure is denoted by this P, is defined as force F, which is divided by the area A, which is the force is applied. So simply this pressure can be expressed as the F divided by A. So the standard unit of this pressure usually is the Pascal. So this 1 Pascal is equal to the 1 Newton per meter square. So what is it? So meter square is the area, and Newton is the force. So we also use this kind of the pressure unit as bar. So this is one of the standard pressure. So usually people usually use this Pascal as a general pressure unit, but in some point there is also this bar is used for the standard pressure. So if somebody say this, what is the standard pressure? You can simply call the as a bar, but the standard unit of the pressure is the Pascal. So you can use the this two system for the unit for the pressures. Okay, so actually the people think about this. Somebody say the pressure, then they simply just think about just this kind of pressure. I mean this kind of air. So this is the most common example what you face in your life as pressure actually. So if some air push this balloon to here, and then we can say there is some kind of pressure. So we can calculate this pressure by dividing this the area of this balloon for this kind of force applied to this balloon. But the how can I say, uh, this kind of Pascal, the pressure actually is the actual physical meaning of this Pascal is the actually force. Actually. So if somebody how can I say, so as a material scientist, if you develop some kind of materials, then the really basic things what you have to do for this material is the measuring this physical property of this material. For usually, especially for this kind of the materials, you usually do this kind of tensile testing. Then you will get some kind of the strength of this material, which is the really important point. What this means? For example, if you buy some kind of a smartphone, and if the smartphone is really easily broken with the small forces, then the smartphone can be sold for this customer, because this looks like just the one-time use the materials. I mean the product. So that's why the one of the important things is the securing the high mechanical strength of some kind of material, which is used for the kind of the product. So that's why people have to test this kind of strength of the materials. So usually the how we can calculate the strength is we can simply divide this force applied to these materials with the area of these materials. Then we will have some kind of strength, and the strength unit of the strength is the Pascal. So what I want to talk to you is if somebody say pressure, then they just think about this kind of the push out forces of some kind of air or something like this kind of things. But actually, the pressure have a really diverse meaning in that word. So that's why we have to always think about this diverse meaning of this pressure, actually. But here, because we will talk about this state of gases, so the thing is that we have to focusing about this pressure is these types of this kind of air pressures. But in the actual situation, there are a lot of different meanings involved in this word of pressure. So that's why, as a material scientist or as engineers, you have to consider different types of this kind of meaning for this pressure too. Okay, so actually, so this is the kind of the common sense for your the future study, but this is actually not the closely related to this physical chemistry. So you don't need to remember these things for your preparation to the midterm or final exam. So, but this is one of the important meaning for your how can I say, so future studying as an engineer in this kind of material scientist departments. Okay, so let's see. So fresh unit is the volt. The standard unit is the Pascal. So the 1 Pascal is the 1 Newton per meter square, and this is the same as the 1 kilogram per meter second. So this is why, I mean, there are many, I mean, in this earth, there are a lot of people, and I don't know why the different people use different unit for this pressure. So actually, the most of people use pressure as a Pascal. I mean, the most widely used this unit for this pressure is Pascal, but somebody also use this kind of Newton per meter square, or somebody use a kilogram per meter second. So that's why the we can how can I say, we don't need to be so embarrassed that because if somebody use this kind of different unit for the pressure. Okay, so the other unit is the bar. This is the standard pressure unit, bar, and the 1 bar is the 10.5 Pascal, 10 to 5 pascals. And also there is the pressure unit, which is the atmosphere. This is the written as the ATM. So 1 ATM is the one around the 100 kilopascal. So what this means, so we are living in this 100 kilopascal. So if you just sit down in your the chair, then you are, how can I say, the having force, external force of 100 kilopascal. So that's why you became tired, even though you just sit down without doing anything, actually. Okay, so the other thing is torque. This torque is the widely used for some kind of the vacuum system. So the one torque is the, how can I say, the about this 133 Pascal. So there is also the pressure unit, which is the millimeters of mercury. This is defined by some kind of the mercury lift up forces of the some kind of air. So this is the actually same value with this torque. So there is also the unit for this pressure, which is the pound per square inch. This is the written as the psi, PSI. So 1 PSI is the about the 6.9 kilopascals. So depending on the situation, we will use different types of the units. But the actually most important thing is the global standard unit of pressure is a Pascal, and the standard pressure, the P pi, can be written as 1 bar. So you have to know at least these two things. This 1 Pascal and 1 bar is the 10.5 pascals. Okay, so let's talk about this mechanical equilibrium. So this is one of the important concept to understand about this state of gases. So let's think about that. So let's see, there is the box here. And we have this movable wall, and this wall is a block. This two part, and this area has a high pressure, and this right hand side is a low pressure. So how this wall will move? Yes, definitely from this high pressure to this low pressure. This wall will move like this until it becomes same pressures for both areas. What about the example B? So in the same boxes, but this area left and right hand side have equal pressures. So what will happen for this movable wall? Yeah, so this will not move in any side. And in the example C, in this case, the right hand side has a high pressure, and this left hand side is the low pressure. Then what will happen? So how this wall will move from this high pressure to this low pressure. So this is a mechanical equilibrium. I mean, for the substance, all this kind of the substance move to make their physical state as I mean became I mean to make this their physical state as equilibrium. So that's why there is the in this kind of example A, the wall is moved from this high pressure to this low pressure. And this example C, the wall move from this high pressure to the low pressure. But if the pressure for this both sides is same, then wall will not move. So this is the concept of this mechanical equilibrium. So for this kind of mechanical equilibrium, the pressure is the important meaning to understand this mechanical equilibrium. Okay, so together. Okay, so how can we make this a pressure? So maybe you might already know about these things too. So this is the how we can measure the pressure. So pressure exerted by the atmosphere is measured with the barometers. What is the barometer? So this is the barometers. So let's see. So if we fill up this kind of a cylinder, glass cylinder with this mercury, and then we just put down this cylinder into this bath filled with this mercury. Then this mercury will move through the bases, but depending on this pressure which is applied to this atmosphere, there's a certain height where the no more mercury can be pulled out from the cylinder through this mercury bases. So this height called as the 1 torr. So depending on this kind of pressure measurement, we can convert this value to the common, how can I say, so common the well-known pressure such as the Pascal or bar. So you understand, right? So yeah, so how can I say? So the as I told you, the air have some pressure. So even though we just sit down in the chair on the chair, but the air is pushing us. So that kind of thing is the atmosphere pressure. So this atmosphere pressure will also push this mercury in this gases, and because of this kind of the pressure from this atmosphere, the mercury inside of this glass cylinder cannot be go out through this passes, and this kind of height made by this kind of atmosphere pressure is kind of a standard unit for this pressure. So usually the for this mercury, this H is the about 760 centimeters. So this kind of system called as barometers. Okay, so you understand, right? Okay, let's go to the next slide. Okay, so let's solve some simple examples. So together. So example 1.1, calculating the pressure exerted by a column of liquid. So what's the example? So derive an equation for the pressure at the base of a column of liquid of mass density rho and height h at the surface of Earth. The pressure exerted by a column of liquid is commonly called the hydrostatic pressure. The method used the definition of pressure, the F equal mg. To calculate this F, we need to know this mass m of the column of liquid, which is its mass density is the rho, and multiplied by its volume, V. So what this means, the m equal rho V. So the first step, therefore, is to calculate the volume of a cylindrical column of liquid. So, so I'll give you just a few minutes, and please solve this examples. Okay, so I think you guys have your own time. You can just pause this movie clip and just solve these things. So anyway, let's solve together. Okay, so how can you solve this thing? So let the column have a cross-section area A. Then what is the volume of this column? So what is the column? So this is this kind of thing called as column. What is it? Which is the cylinder. So this, if this column has a cross-section area A, then its volume is the AH because the height is H. And what is the mass for this the column? So because this M equal rho V, what we have already derived from this previous part, then its mass is M equal rho M equal rho AH. So the force the column of this mass exert at its base could be F equal mg and m equal rho AH, and this is G. So therefore, the pressure at the base of the column is the pressure. So what is the pressure? Pressure is the force divided by A. So what is the force? Force is the rho AGH, and we can divide this with A. So this will be removed here. So finally, pressure is equal to the rho GH. So this kind of a system called as the hydrostatic pressure. Actually, this is the not mathematical problem actually. So this is the how can I say the how this is the to check the how you will understand about some kind of a physical terminology. So actually, all these kind of things you might already. I mean, actually, all these kind of things you might already learned in your previous classes. I mean, not this class. I mean, the other classes in your freshman classes. So, for example, general physics or general chemistry. So, the most of this kind of example is quite closely related to this kind of a basic concept of such things, such classes. So that's why to solve this kind of example, you have to at least know some basics of that things. So anyway, so let's see. So anyway, so we have so anyway, so this is called as hydrostatic pressure. So note that this hydrostatic pressure is independent of the shape and the cross-sectional area of the column. So what this means? So let's see. So finally, we call that this pressure. So rho, the rho is the mass density. G is the gravity, H is the height from the surface of the Earth. So what this mean? So the pressure applied to this column is not related. I mean, it's not depending on the shape or cross-section area of the column. So it just depending on this kind of mass density or gravity or height. I mean, so this is the matter of the mass. It's not the matter of this the shape of this column. So that's why we call that kind of thing is the hydrostatic pressures. So the mass of the column of a given height increases as area, but so does the area on which the force acts. So the two cancel. So what this means? So even though we have used the large column, but the force, I mean the pressure, is not increased depending on the size of this column, because the term of this column, area column, because term of the size of the columns is cancelled. Yeah, so this is the basic concept. There's some simple example of the hydrostatic pressure. So I don't I didn't say you should remember this equation, but and how can I say? I should say that you have to understand why this kind of equation is derived from this system, and how this kind of hydrostatic pressure is depending on this kind of variant of this equation. Yeah, this is the one of the basic example of this physical chemistry. Okay, so this is the how can I say, the kind of the equipment to measure the pressure. So maybe you might see this kind of gauge in some kind of how can I say, if you use some vacuum system, or I'm not sure, but there is some kind of gas values or gas pump, then such things usually have this kind of the gas measurement system. So this is called as the Bourdon gauge. So this can measure the high pressure. So it's a kind of clock-like system. So there is some gas, and if there's gas, there's a pipe, and gas will make a pressure onto this pipe, and this pipe connected with this kind of measuring the component. And depending on this the size of this pressure, there could be some spring. The force is the fixing this spring will be changed. Then we can measure the pressure by using this system. Okay, so the other type is the Bayard Alpert pressure gauge. So this is the really the how can you say, high precise pressure measurement system. So if we have really low pressure, then we want to know the that pressure size. Then we can use this kind of the cylindrical types of the gauge. So there is the how can I say, the this is the how can I say? There is some kind of coil, and this coils emit electrons. And by this electron, that kind of ion can be emitted too. And depending on the gas flow through this the chamber, the electron or ion, the movement will be changed. So we can detect the kind of signal change, then converting that kind of change to the pressures. So for that kind of system, we can call this a Briard Alpert pressure gauge. So this is also one of the really common system to measure the pressures. Okay, so I think we'd better have a summary in Korean here, and then stop this week here, and then continue this class further in the next week. 네, 그 한글말로 간단히 좀 정리만 좀 해드리고 오늘 수업은 마무리를 좀 짓도록 하겠습니다. 네, 별로 어렵진 않으셨죠? 그러니까 오늘 내용들이 그렇게 어려운 내용들이 없어요, 사실. 네. 사실 물리화학 첫 번째 내용들이 그렇게 어려운 내용들이 많지 않습니다. 그리고 전반적으로 제가 수업 자체를 그렇게 어렵게 진행을 할 생각이 전혀 없기 때문에 여러분도 그렇게 부담을 갖지 않고 수업을 들으셔도 될 것 같고요. 네, 그렇습니다. 네, 아무튼 그래서 일단은 그 기체 평형 상태, 그러니까 지금 이 물리화학 시간에서 사실 물리화학 1도 그렇고 2도 그렇고 대부분 저희가 이제 많이 다루는 게 이제 기체죠. 사실 물리화학에서는 결국 다루고 있는 것들이 기체, 뭐 액체, 기체 뭐 이런 걸 다루고 있는데 네, 그래서 지금 우리가 그러니까 연력학이라는 것도 결국은 이젠 이 기체의 특성에서부터 시작을 하는 거기 때문에 우리가 이제 기체에 대해서 지금 다루고 있는 거고요. 그래서 이제 가장 처음에 시작하는 게 이제 평형 상태에 대해서 먼저 이제 그 설명을 드리게 됐었고요. 그러니까 평형이라는 게 뭐냐 하고 뭐 하면은 굳이 여러분에게 설명을 드리지 않아도 영어로 이미 다 설명한 것처럼 어떠한 그 움직임이 없는 어떤 상태, 안정적인 상태가 가장 평형적인 상태다라고 생각을 하시면 될 것 같고요. 그래서 어쨌든 간에 이 이론에 대한 것들을 이렇게 도출을 하는 데 있어서 이 평형 상태에서 항상 시작을 하게 되죠. 왜냐하면 그 변수들이 많으면 결국은 우리가 뭐죠? 그런 것들을 바탕으로 결국 이론이라는 건 뭐라면 결국 우리가 수식을 만들어내는 과정인데, 그러니까 어떠한 그 현상에 대해서 이 현상들을 일반화할 수 있는 수식을 만드는 게 바로 이 이론화가 되는 과정들인데, 근데 이런 일반화를 시키는 이론되는 과정 중에서 굉장히 많은 변수가 있다면 사실 이게 일반화가 될 수가 없죠. 그래서 결국은 가장 완벽한 상태에서 시작을 해서 거기에 추가적으로 이런 변수가 있을 때는 이 상태에서 이렇게 변한다 하고 도출해 나가는 과정이 바로 이런 이론들이 정립되어 나가는 과정인 거죠. 네. 뭐 그렇기 때문에 평형을부터 시작을 한다. 이거는 그냥 상식적으로 여러분에게 말씀을 드렸던 내용이고요. 여러분이 앞으로 계속 공부하는 꼭 이 수업뿐만 아니라 대부분의 어떠한 수업에 있어서 그 이론을 정립하는 과정이 그런 식으로 진행이 된다 하는 걸 여러분이 아시면 될 것 같고요. 네, 그래서 이 물리화학 시간에서는 가스의 상태, 기체 상태에 대해서 좀 배울 거고 사실 뭐 지금 계속 핵심적으로 얘기했던 거는 프레셔에 대한 내용이고요. 프레셔가 뭐고, 프레셔는 force를 면적으로 나눈 값이다. 그래서 지금 오늘 이 템퍼러처에 대한 거는 사실 오늘 자세하게 다루지는 않았고요. 메케니컬 이퀄리브리엄에 대해서는 좀 다뤘었는데, 이 기계적 평형 상태에 있어서 중요한 요소 중에 하나가 프레셔다. 여러분이 영어로 했던 부분에 대해서 다 하시면은 사실 이 한글로 된 서머리는 사실 그냥 넘기셔도 됩니다. 사실. 그래서 프레셔는 이런 바로미터라는 걸로 측정을 하고, 그리고 제로스로우라는 게 있다. 이것도 사실 여러분이 다 아는 내용이죠. 제로스로우. 그래서 A랑 B가 평형이고 B랑 C가 평형이면 A랑 C가 평형이다. 뭐 당연한 얘기 같지만 사실 이게 또 당연하게 아니었다라는 걸 여러분께 말씀을 드렸던 거고요. 그래서 어떠한 그 메케니컬 이퀄리브리엄이든 서멀 이퀄리브리엄이든 어떠한 평형 상태를 설명하는 데 있어서 가장 핵심적인 내용이 메케니컬 같은 경우는 프레셔고 서멀 같은 경우는 템퍼러처다 하는 걸 좀 아시면 될 것 같고, 피지컬 스테이트라는 거는 어떠한 그 물리적 상태에 따라서 이 피지컬 어떠한 그 기체의 상태, 어떠한 그 물질의 상태가 물리적 상태가 결정이 된다는 거를 얘기하는 뭐 당연한 얘기였던 거였고요. 그리고 상태 방정식이라는 거는 어떠한 피지컬 그 프로퍼티와 관련된 식들을 설명하는 게 상태 방정식. 그러니까 여러분이 지금부터 사실 이렇게 해 나갈 때 지금부터 이제 배워 나갈 것들이 이러한 상태 방정식들이 어떤 것들이 있는가 하는 그런 것들을 여러분이 배울 거죠. 그리고 General Form of Equation of State라고 되어 있는 거는 이제 이상기체의 상태 방정식. 아까 그 상태 방정식의 어떤 General Form은 압력. 그러니까 이게 상태라는 게 결국은 Physical State를 얘기한다고 했잖아요. 이 Physical State, 어떤 그 물질의 그 물리적인 상태가 어떤지를 설명하는 데 있어서는 결국은 이 물질은 온도와 볼륨과 가스니까 뭐 분자량들에 의해서 물질의 상태가 결정이 된다. 이거를 여러분이 이제 아시면 될 것 같고, 그리고 특히나 이상기체의 상태 방정식은 굉장히 유명하게 알려진 수식이겠죠. 압력은 nRT분의 V다. 뭐 이건 뒤에서 계속 다시 한번 설명을 드릴 거고요. 어쨌든 굉장히 이렇게 유명한 식들이 있다. 뭐 수업 전반적으로 여러분에게 뭐 수학적인 뭘 이렇게 막 강요하고 이러지는 않을 겁니다. 그래서 너무 수학에 대한 백그라운드가 없다고 걱정하실 필요는 없고요. 그냥 쉽게 진행할 될 예정이니까 그렇게 너무 물리화학에 대해서 어렵게 생각 안 하셨으면 좋겠어요. 그래서 뭐 아까 했던 말 똑같은 거죠. 프레셔는 뭐 P는 A분의 F다. 이렇게 했었고, 단위가 파스칼이라는 단위를 씁니다. 여기는 뉴턴 퍼 미터 마이너스 2승. 뉴턴 퍼 미터 제곱. 혹은 뉴턴 곱하기 미터의 마이너스 2승. 이렇게 설명이 되는 거죠. 그리고 스탠다드 프레셔라고 하는 게, 그러니까 이게 사실 그냥 글로벌 규격은 파스칼을 쓰는데 그냥 일반적인 그냥 뭐 그러니까 기준 압력이라고 하죠. 그냥 기준 압력은 그러니까 유닛은 파스칼이고 기준 압력이라는 게 또 있어요. 어떠한 그 압력을 얘기할 때 기준 압력이 되는 거는 뭐 1바라고 보통 얘기를 합니다. 근데 뭐 파스칼을 가장 많이 쓰긴 하고요. 근데 막 사람들마다 중구난방으로 쓰기는 해요. 근데 그래서 이제 뭐 이렇게 다양한 다양한 그 단위들에 대해서 여러분하고 좀 얘기를 했던 거고요. 근데 여러분 이제 다른 거는 모르겠고 이 두 개 정도는 이제 기억을 하시면 돼요. 요거는 사실 상식이죠. 1ATM이. 이게 우리가 사실 여러분이 살면서 이런 단어들을 지금 계속 많이 그 보실 텐데 뭐 ATM 이런 것도 많이 쓰잖아요. 토로도 볼 거고 MMHG, 사이 뭐 이런 거 다 볼 텐데 이게 이 파스칼과 어떤 관계가 있는지에 대해서 뭐 이런 완전히 기억할 필요 없고 아 이렇게 파스칼과 이런 식으로 계산이 되는구나 하는 정도로만 여러분이 아시면 됩니다. 사실 요거 정도는 기억하시면 좋을 것 같아요. 1반은 10의 5승 파스칼이다. 요 정도는 굉장히 좀 많이 쓰이기 때문에 기억을 해주시면 편리할 것 같습니다. 그리고 메케니컬 이퀄리브리엄이라는 거는 결국은 이제 이 동적인 움직임이 평형이 된 상태라고 생각을 하시면 돼요. 그러니까 압력 차이가 있으면 높은 압력에서 낮은 압력으로 이게 물리적으로 움직인다. 그러니까 압력에 의해서 이게 움직여 버리는 거죠. 근데 평형일 때는 움직이지 않고. 그래서 이게 메케니컬 이퀄리브리엄에는 어떠한 그 힘에 의한 평형, 힘의 평형이라고 생각을 하시면 돼요. 그래서 서로 이렇게 힘을 손바닥으로 밀고 있는 상태에서 움직이지 않고 있으면 둘이 힘이 평형이 된 상태인 거죠. 한쪽으로 밀리면은 이제 그 힘의 평형이 깨진 거죠. 어쨌든 그런 힘의 평형의 상태를 메케니컬 이퀄리브리엄이라고 하고, 결국 우리가 힘이라고 얘기를 하지만 이게 결국은 프레셔라는 거죠. 네, 압력이라는 거죠. 그래서 그 얘기를 제가 아까 전에 영어로 굉장히 길게 좀 설명을 했었습니다. 그리고 마지막으로 프레셔를 측정하는 방법의 대표적인 거죠. 이게 바로미터라고 여러분 많이 들어봤죠? 이게 수은에 실린더 이렇게 집어넣으면 이 공기 압 때문에 프레셔 때문에 공기에 의한 프레셔 때문에 이게 더 이상 내려오지 않고 요 높이를 기준으로 하는 게 바로미터인 거죠. 그래서 여기가 760이잖아요. 요게 바로 요거죠. 1 mmH 요거죠, 사실. 요 1토로 1 mmH. 네. 그리고 여기서 이제 하이드로스태틱 프레셔에 대해서 여러분 같이 계산을 해봤는데, 요거는 이제 사실은 이 수식을 얻어내기 위해서 지금 여러 가지 컨셉들이 지금 쓰였잖아요. 이런 것들을 여러분이 어떻게 이해를 하시는가 하는 것들이고, 결국은 이 프레셔를 할 때 뭐 컬럼의 사이즈가 변한다고 해서 이게 뭐 압력이 변한다거나 이런 게 아니다. 네. 이거의 압력은 결국 물질과 높이와 이 메터의 중력 이런 것들의 상관관계지 어떤 뭐 용기의 차이에 의해서 이게 바뀌는 건 아니다 하는 걸 여러분에게 보여주기 위해서 이거를 좀 했던 거고요. 그래서 요거는 한번 여러분이 이해를 해보시면 좋을 것 같아요. 이해를 좀 하시고, 그리고 압력계에 대해서도 여러분하고 같이 이야기를 좀 나눠봤었습니다. 그렇게 어려운 내용은 없었을 거라고 생각이 되고요. 숙제는 사실 이거 크게 의미는 없는데 요 내용, 요 표를 직접 손으로 한번 써보세요. 압력의 단위가 어떤 게 있고 이게 서로 어떤 상관관계가 있다 하는 거를 손으로 한번 써보는 게 숙제입니다. 그래서 이거를 꼭 핸드라이팅을 해가지고 핸드라이팅을 해서 사진을 찍어서 이 클래스에 올려주시면 돼요. 제가 이거는 또 이 클래스에 설명을 좀 드리도록 하겠습니다. 네, 그러면은 오늘 수업은 여기서 이렇게 마치도록 하고요. 다음 시간에 수업을 이어서 더 하도록 하겠습니다. 네, 고생 많으셨고요. 네, 이 클래스 계속해서 여러분 확인하시면서 뭐 공지사항이나 이런 것들 뭐 이렇게 놓치지 않도록 계속 좀 확인을 하시면 좋을 것 같아요. 네, 그럼 수고하셨습니다.